Excellent workshop is going on under the flagship of the IQAC. So that's why on behalf of though I'm not a lady of sciences stream, I'm a lady of the humanities. So that's why I know that each and every workshop has is over to the Department of Mathematics. Thank you very much. Though I'm not a lady of sciences stream, I'm a lady of the humanities. So that's why I know that each and every workshop has is over to the Department of Mathematics. Thank you very much. Though I'm not a lady of art,
Thank you so much, ma'am, for your consult. As yesterday we learned a lot in this workshop, so by continuing this way of learning, I would like to invite today's first speaker, Dr. Saraswati Shah, ma'am, from UNAM, Mexico. She is a postdoctoral fellow at Institute of Mathematics, National Autonomous University of Mexico. She was gold medalist in her post graduation. She obtained her PhD degree from the Department of Mathematics at the University of Delhi. She has investigated the propagation of blast waves and their interaction with different waves in real reacting gases with dust particles and non-ideal relaxing gases via exact and numerical solutions. Her research interests are hyperbolic conservation laws and system with non-conservation products, numerical simulation and Riemann problems, group theoretic solutions of quasi-linear partial derivative equations, shallow water flow, traffic flow, geophysical fluid dynamics, and atmospheric sciences. I hereby take a pause and welcoming ma'am. Ma'am, please may you share your valuable knowledge with us.
Yeah, thank you, dear, for this kind introduction. So today I am going to talk about partial differential equation, and I think you guys might be aware of my talk topic. So I will join with another device as well to present the. Okay. So how many of you are aware of the partial differential equation? I can see that there are PhD students and master students as well with the undergraduate students. So I hope that all of you are aware of partial differential equation. I think it is taught at undergraduate level. So I hope my screen is visible to all of you. Am I audible to all of you?
Yes, ma'am.
Okay, thank you.
Yes.
So before giving the introduction of partial differential equation, I will give a very few lines about the ordinary differential equation. So what is the difference between ordinary differential equation and partial differential equation? So in ordinary differential equation, there is only one independent variable. There is only one independent variable. I think everyone is aware of population growth. So you can see that the number of population increase or decrease by the time. It doesn't depend on any other variable. So the number of population only depend on time. So to see the growth, like to see the increment or decrement in the number of population of any country, we write an ordinary differential equation that depends on time. Now, for the partial differential equation, there may be more than one independent variable. More than one independent variables. So suppose you take a ball, a cricket ball, and you just throw it. So how it changes? It speed change with respect to time and also with respect to distance. Means it speeds depends on time and space variable. That is, there are two variables. In this problems, there are two variables. So this is not defined by ordinary differential equation. So this comes under partial differential equation. And today I am very interested to talk about the first order partial differential equation. That is a very basic of partial differential equation. So we will discuss about the solution of this differential equation. And if our time allows us, then we will also go over some real life examples. Yeah. So firstly, we will talk about the first order partial differential equation. We know that first order partial differential equation arises in a large number of physical processes. A first order partial differential equation arises a large number of physical processes. So its study is important from mathematical and from theoretical point of view. And also if we go over the geometry, then it becomes more interesting. So how we represent the first order partial differential equation? Suppose there is one unknown variable u, and there are two independent variables x and y. There may be more than two independent variables, but for this talk I am going through a very basic partial differential equation. So we are assuming that there are two independent variables x and y and one unknown variable u that depends on this x and y. So a first order partial differential equation in two independent variables can be written as x, y, u, that is a known variable that depends on x and y, ux, uy. Partial derivative with respect to x, treating y as a constant, and partial derivative with respect to y, treating x as a constant. So this is equals to 0. So what is u? U is a known variable and x and y is and y. So basically we are going to find out the value of u which depends on x and y by solving this partial differential equation. Okay. So if anyone has doubt, then please ask me. Okay. Next, we will go through the classification of partial differential equation. This is a very important part of this talk. This classification is very important part of this talk because by seeing the classification of PD, by seeing the nature of PD, we can see whether we will be able to derive the solution or not. So this classification is very important. Differential equation. Firstly, I will write Cauchy linear PD. So a PD of the form A, x, y, u, ux plus b, x, y, u, uy equals to c, x, y, u. A Cauchy linear of the form where the highest order derivative or first order partial derivatives is, I am talking about a first order partial differential equation. So the highest order derivative has order 1. The highest order derivative has order 1, like that is it is linear, but their coefficient are function of u, that is u may be non-linear. Here